Hi all, welcome to Sankalp Learning Classes. In this session, we'll be going to discuss the 1 mark questions from the chapter Inverse Trigonometric Functions. So in total, you will get 6 mark questions from this chapter. That is a 1 mark question, then there will be a 2 mark question and as well as a 3 mark question. In total, you will get 6 mark question, and in this session, we'll be dealing with the 1 mark questions of the chapter. All right. So before going to the discussion, we'll just have a quick reflection on what we have studied till now. That is, I hope that everyone know what are the inverse trigonometric functions, and we have studied about the domain as well as the range of these functions. So it is very important for you to know the domain as well as the range of inverse trigonometric functions in order to solve the problems, especially this 1 mark question. For everything you should know, but if you don't know at least the domain and ranges of these functions, you cannot answer the 1 mark question properly. All right, completely it is based on that topic. So we'll just have a quick reflection on what is the domain and ranges of each inverse trigonometric functions. All right, so for that, we have already discussed this, and we grouped in order to memorize these principal value, branch, and domain. We group these inverse trigonometric functions into two, isn't it? We have grouped these y equal to sine inverse, similarly tan inverse, and the reciprocal of sine inverse is cosec inverse, isn't it? So we have grouped these into one because all these have the lies within the principal branch, like minus pi by 2 to pi by 2, but there is a slight difference, so we can group that group these three together, isn't it? This is just to memorize the domain and the range of the functions. All right, so here you can see that sine inverse x, the principal value branch is minus pi by 2, which is closed interval minus pi by 2 comma pi by 2. And what about tan inverse? Tan inverse is open interval minus pi by 2 comma pi by 2. That is minus pi by 2, and pi by 2 is not included. In between, all those values are included in the principal value branch of tan inverse x, isn't it? Now, what happens to the reciprocal of sine inverse, that is cosec inverse x? Cosec inverse is the principal value branches closed interval minus pi by 2 itself, but a point is removed. What is that point? The set 0. Okay, 0. The point 0 or set 0 is removed. Okay, what you can say that 0 lies in between minus pi by 2 and pi by 2. So the midpoint is removed from that principal value branch. All right. So this is how you study in order to memorize the range. All right. So similarly, we can group the other three together. So these three can be grouped together, isn't it? So cos inverse, the range is closed interval 0 pi. So what happens to cot inverse? Cot inverse will be open interval 0 pi. Now cos inverse, reciprocal of cos inverse is nothing but sec inverse. So what will be the principal value branch of sec inverse? It is nothing but closed interval 0 pi, but the midpoint of this 0 and pi is pi by 2. So we have to remove that one. So minus set pi by 2. Okay. So these are the principal value branches of inverse trigonometric functions. Similarly, you should also know the domain of these functions also, and it is also very easy. You should know only three. Okay, sine inverse and cos inverse have closed interval minus 1, 1. That is the domain. And what about tan inverse? You can see tan inverse and cot inverse has the complete set of real numbers as the domain, isn't it? And what happens to sec inverse and cosec inverse? Sine inverse, the reciprocal of sine inverse is cos inverse. Sine inverse, it is closed interval minus 1, 1. And cosec inverse, it will be r minus open interval minus 1, 1. So whenever you study this domain and principal value branch, you try to connect these things, and it will be helpful for you to memorize the domain as well as the range. All right. So here you can see that cos inverse is closed interval minus 1, 1, and its reciprocal is sec inverse. So what is the domain? Domain is the set of all real numbers minus open interval minus 1, 1. Okay, here it is closed interval minus 1, 1. Here it is open interval minus 1, 1. All right. Now we are moving on to the problems. Okay. So we'll discuss the problems one by one, and if there is any other theory that is applicable to solve that problem, we'll discuss that at that particular moment. Okay, so we'll start with doing the first problem. The first problem is the principal value branch of the principal value branch. Okay, I'm writing it as PVB. The principal value branch of f of x is equal to tan inverse x. The principal value branch of f of x equal to tan inverse x. The first option is open interval minus pi by 2 comma pi by 2. Then open interval 0 pi. Then closed interval minus pi by 2 comma pi by 2. Then closed interval 0 pi. Alright, so what is the principal value branch of this function? What is the function? Tan inverse x. And we have already studied the principal value branch of tan inverse is nothing but open interval minus pi by 2 comma pi by 2, because we have grouped these sine, then its reciprocal cosec and tan as a group, isn't it? So it was all based on this minus pi by 2 and pi by 2. And when it comes to the function tan inverse, it is open interval minus pi by 2 comma pi by 2. And if you are asked the function f of x equal to sine inverse of x, then what will be the answer? It will be C, closed interval minus pi by 2 comma pi by 2. If you are asked about the function cos inverse x, what will be the answer? It is nothing but closed interval 0 pi, isn't it? So this you might get a question based on this. It may be asked in a different form also. Okay, I'll explain it in the third question. So the second question is, you have to say the domain of f of x is equal to cot inverse x. Okay, the options are minus 1 comma 1, then B minus infinity comma infinity, it is closed, then open minus infinity infinity, then the fourth option is open closed interval minus 1 comma 1. So what is the domain of the function cot inverse x? We know that the domain of tan inverse x as well as cot inverse x is a set of all real numbers, isn't it? The set of all real numbers means it contains all the number, which means it extends from minus infinity to plus infinity, isn't it? If you are writing the set of all real numbers in the form of an interval, how will you write it? How will you write it? It extends from minus infinity to infinity. And can you use closed brackets to represent minus infinity? No, you should always use open brackets when you write about infinity. Okay, if the endpoints of an interval is infinity, then you should only use open bracket. You should never use closed bracket. So how will you write the set of all real number? Set of all real number can be written in an interval form as open interval minus infinity comma infinity. So what is the answer here? Since the domain of the cot inverse is a set of all real numbers, we can say that the answer for this question is nothing but C. Okay, minus infinity comma infinity. So we are moving on to the third question. If cos inverse x equal to y, then B is minus pi by 2 less than y less than pi by 2. Then C is 0 less than or equal to y less than or equal to pi. And then D option is 0 less than y less than pi. Alright, so cos inverse x is equal to y. Then they are asking about what they are asking about. They are asking about the range of y. Okay, since from the options you can understand that they have given that the range of y. All right. So what is y? Y is nothing but cos inverse x. It is the inverse function cos. Okay, inverse function cos. So we know the range of cos inverse x. What is the range of cos inverse x? It is closed interval. It is the principal value branch of cos inverse x is nothing but closed interval 0 pi, isn't it? Closed interval 0 pi is the principal value branch of cos inverse or the range of cos inverse. Okay, so here y is the range of cos inverse because cos inverse x, they have given that cos inverse x is equal to y. So how can you write this in the form of given in the question? How can you write closed interval 0 pi? Isn't this the method? That is, y lies in between 0 and pi, where 0 and pi are included. Here it is closed bracket. So 0 and pi are included in the value of y. So how will you write this in the form of given in the question 0 less than or equal to y less than or equal to pi, isn't it? The y varies in between 0 and 0 and pi are included. So we have to use a less equal to symbol also. Okay, 0 less than or equal to y less than or equal to pi. So C is the answer. Most probably you will have a question from this. It can be a different function. Okay, here you have got cos inverse x. It can be tan inverse x or it can be sec inverse x. Okay, so you should thoroughly know what is the range of a inverse trigonometric function and how to write this in different forms, in forms of interval or if it is in the given question, something like that. Okay, so now we are moving on to the fourth question. Write the write the range of f of x equal to sine inverse x other than closed interval minus pi by 2 comma pi by 2. Okay, write the range of f of x equal to sine inverse other than minus pi by 2 comma pi by 2. The options are closed interval 0 pi, then closed interval pi by 2 comma 3 pi by 2. Then third option is open interval 0 pi. Then fourth option is minus pi comma pi. All right. So we know the principal value branch of the function sine inverse x is nothing but closed interval minus pi by 2 comma pi by 2. Isn't it? Closed interval minus pi by 2 comma pi by 2 is the range of the function sine inverse x. All right. So they are asking about another range. Okay. So we know that in the set of the sine inverse x or the function sine x is invertible only in restricted intervals. One among the interval is minus pi by 2 comma pi by 2. So the other interval will definitely be a multiple of this one itself, that is pi by 2, isn't it? So here you know that in closed interval 0 pi, can we say sine inverse x exists? Sine inverse x does not exist because it will not be 1, 1. Isn't it? We have already explained detail in the previous classes. So you have to watch it, then you will clearly understand the concept. If I explain it with the help of a graph, um, so here you can see the sine inverse. This is a graph of the sine inverse function, sine inverse x. Okay, here you can, they have marked the we have marked the principal value branch. Okay, this is the principal value branch. It varies from minus pi by 2 to pi by 2. Okay, how did you got that interval? In that particular interval, we can see that the function is 1, 1 and on 2. So we can say that it is invertible. So that's why sine inverse x exists in that particular interval. Similarly, we can find another other intervals also, isn't it? You can find if you take the first option was 0 to pi, isn't it? 0 to pi. So this is starting from 0 and it extends from here pi to pi up to pi. Okay, that is 0 to pi is marked there. Can you say that it is invertible in that particular interval? No. Why? Because it is not 1 1. Why it is not 1 1? Why it is not 1 1? Here you can see that if I draw a line like this, if I draw a horizontal line like this, look at that graph. What is happening? It is touching in more than 1 point, isn't it? It is touching in more than 1 point means it has two images, more than one image, which means it is not 1 1. So it is not invertible in that particular interval. So we cannot take that interval because that in that interval the function, the inverse function does not exist. So we cannot consider that one. So we can consider this one, isn't it? We can consider this one, pi by 2 to 3 pi by 2 we can consider. Similarly, we can consider this portion also. What is that? Minus pi by 2 to minus 3 pi by 2, which means the range of sine inverse x will definitely be a multiple of this pi by 2. Okay, so we can take again minus 3 pi by 2 to minus 5 pi by 2. Okay, so here this portion can be taken. Okay, similarly we can take this portion also, that is 3 pi by 2 to 5 pi by 2. Now let us see whether we can answer that question. So this was our question. Write the range of f of x equal to sine inverse other than minus pi by 2 to pi by 2. So what is the answer? It is option B. It is option B. Okay. Pi by 2 comma 3 pi by 2. In that particular interval, in the function sine inverse exists. All right. All the other intervals, we have already understood that the sine inverse x does not exist. All right. So we are moving on to the next question. In which of the following, the inverse of the function y equal to cos x does not exist. The options are closed interval 0 pi, then closed interval minus pi by 2 comma pi by 2, then comes the interval closed interval pi comma 2 pi, then closed interval minus pi comma 0. All right, in which of the following the inverse of the function, that is y equal to cos x is our function, and they are asking in which of the given intervals the inverse does not exist. So we have to find out the interval in which the y equal to the cos inverse of function cos inverse of x does not exist. Okay, since y equal to cos x, its inverse is cos inverse, isn't it? So cos inverse x does not exist. So what is the principal value branch of cos inverse x? We know it is nothing but closed interval 0 pi. It is closed interval 0 pi. Okay, it is closed interval 0 pi. So we know that in that particular interval, cos inverse definitely exists. So what about closed interval minus pi by 2 comma pi by 2? In that interval, does the inverse of the function cos exist? No. Isn't it? Why? What is the reason? Because it is not 1, 1 in that particular interval. Again, it was already explained with the help of graph in the earlier sessions. Here you can see that minus pi by 2 to pi by 2 is like this. If I mark it like if I mark the portion, it will be like this. Okay, minus pi by 2 to pi by 2. Again, it is not 1 1. Clearly, it is not 1 1. So inverse of the function does not exist in that particular interval for the function cos. Okay, so we have got the answer, isn't it? The question was to find out the interval in which the inverse of the function does not exist. It is nothing but minus pi by 2 comma pi by 2. All right. Next question is sine inverse of sine x. They have given that sine inverse of sine x is equal to x, and it is defined on, in which interval is this property defined. We have studied different properties related to inverse trigonometric function. Mainly this is the property that you have to study, that is sine inverse of sine x is equal to x, or you can say that sine of sine inverse x is equal to x, and this property is applicable to all the other inverse trigonometric function, isn't it? So they are asking, they have given that sine inverse of sine x is equal to x, but they are asking in which interval is this defined. Okay, in which interval is this property defined? All right, the first option is x belongs to closed interval minus pi by 2 comma pi by 2. Then the second option is x belongs to open interval minus pi by 2 comma pi by 2. And the third option is x belongs to closed interval 0 pi. Then the last option is x belongs to open interval 0 pi. So can you say in which interval is this defined? Which interval does x belongs? Clearly x belongs to closed interval minus pi by 2 comma pi by 2, isn't it? X belongs to closed interval minus pi by 2 comma pi by 2, because here we are talking about the function sine inverse, isn't it? Okay, the bracket in sine inverse, inside the bracket you can see that sine x. So basically we are talking about the function sine inverse, isn't it? So sine inverse, we know the range of sine inverse is nothing but closed interval minus pi by 2 comma pi by 2. So if the answer is x, if the answer is x, then that x definitely should belongs to the principal value branch of that function, isn't it? So x belongs to closed interval minus pi by 2 comma pi by 2. Okay, now this question may be asked like this also, that is sine inverse x is equal to x, and they will ask where is this x belongs to. Here we are talking about sine. Here we are talking about the function sine. So what is the sine, the range of this function sine? It is nothing but x should belongs to, we know the range is nothing but minus 1 1, isn't it? The range of sine function is closed interval minus 1 1, so that x should definitely belongs to minus 1 1. Okay, now we are moving on to the next question. The value of sine inverse of sine 160. The value of sine inverse of sine 160. The options are 160, then 70, then minus 20, then last option is 20. All right. So can you say the answer for this question? Again, it is that property. The property is applicable, isn't it? Sine inverse of sine 160. The answer will be 160. Is that right? Is that right? No. Because what is the reason? 160 does not belongs to the principal value branch. Here it is sine inverse. So what is the range of sine inverse? It is closed interval minus pi by 2 comma pi by 2. Minus pi by 2 comma pi by 2 means minus 90 to 90. Minus 90 to 90. So 160 does not belongs to this particular interval, minus 90 to 90. So what should we do? We should equivalent angle of 160-degree that belongs to the principal value branch of the function. Okay, what we have to do? We have to find out the equivalent angle of 160-degree that belongs to the principal value branch of the function sine inverse x. So how will you do that? We should use a reduction formula that we have studied in the trigonometry, isn't it? So how will you do? That is sine 160. I can write this one as sine 180 minus 20. Isn't it? 180 minus 20 is 160. So what happens here? If I draw like this, okay, 180 minus 20 means 180 minus 20. Here, this is 180, isn't it? 180 minus 20 means if I subtract 20 from this, it will reach here. Okay, this is the second quadrant. This is the first quadrant, second quadrant. This one is third and this one is fourth. Here we know the code like all silver teacups, isn't it? Here, every trigonometry functions are positive. Here, sine is positive. Here, tan and its reciprocal, cot is positive here, cos and its reciprocal, sec is positive. Okay, except all the functions here, all the other functions are negative. So if this 180 minus 20 means it is in the second quadrant. In the second quadrant, we know that sine is positive. So sine is here, sine is positive. So this can be written as sine of 180 minus 20 can be, since sine is positive, sine 20. Isn't it? Sine of 180 minus 20 is equal to sine 20 in the second quadrant. All right. So we have obtained the equivalent angle. Sine 160 is equal to sine 20. Okay. So sine inverse of sine 160 can be written as sine inverse of sine 20. All right, now we can apply the property sine inverse of sine x is equal to x. Over here, x in the place of x is 20. So sine inverse of sine 20 is equal to 20. And this 20 belongs to the principal value branch minus pi by 2 to pi by 2. Isn't it? It lies in between minus 90 and 90, 20. Isn't it? So we can say that the answer is sine inverse or sine 160 is nothing but 20. So option D. Next, we are moving on to the next question. the value of cosec inverse of 2. The value of cosec inverse of 2 is equal to dash. You might get a question in the form of MCQ, or it can be in the form of fill in the blanks. So here it is given as in a fill in the blanks form. So the value of cosec inverse of 2, you have to find out the value of cosec inverse of 2. So these questions are always solved with the help of that property. That is cosec inverse of cosec x is equal to x, isn't it? So we know the property cosec inverse of cosec x is equal to x. The condition is that this x should belongs to the principal value branch of the function cosec inverse. All right. So this 2 can be, 2 should be, okay, 2 should be written in the form of cosec x. 2 should be written in the form of cosec x. That is, we have to find out the value of x in which cosec x will give you 2. Okay, that is cosec x should be written in the form of 2. How will you find out the value for x for which the function cosec will give you 2? How will you find it? We will think it in the reverse manner. That is, you consider the reciprocal. Since we don't know the standard functions of cosec, we know the standard values of its reciprocal sine, isn't it? So you think it in a reverse manner. That is, you think about its reciprocal. Okay, so that is 1 by cosec x is equal to 1 by 2. What do you mean by 1 by cosec x? It is nothing but sine x. So sine x is equal to 1 by 2. So you find out the value of x in which sine will give you 1 by 2. Then you'll automatically get the value of cosec x. All right. So sine x is equal to 1 by 2 means sine 30. Isn't it? Sine 30 is 1 by 2. That means sine pi by 6 is 1 by 2. Which means if sine pi by 6 is 1 by 2, what about cosec pi by 6? Cosec pi by 6 is equal to 2. It's reciprocal. Sine pi by 6 is 1 by 2. So it's reciprocal. Cosec pi by 6 is reciprocal of 1 by 2. It is 2. Okay, so this 2 can be written as cosec inverse of 2 can be written as cosec inverse of cosec pi by 6. Here you have got that 2 is equal to cosec pi by 6. So I have replaced this 2 with cosec pi by 6. All right. So cosec inverse of cosec pi by 6. So that is equal to value is pi by 6. And you have to check whether this belongs to the principal value branch. What is the principal value branch of cosec inverse? Cosec inverse belongs to the first group, that is sine, tan and cosec, isn't it? So the sine starts with closed interval minus pi by 2, pi by 2. So this is also closed interval minus pi by 2, comma pi by 2, the principal value branch. But you should remove the midpoint. What is the midpoint? 0, right? So you should remove that midpoint, that is 0. So does pi by 6? Pi by 6 means 30 degree. 30 degree belongs to this one. Definitely. 30 degree belongs to, this is minus 90 and plus 90. So 30 degree means pi by 6. Pi by 6 belongs to this interval. So we can say that cosec inverse of 2 is nothing but pi by 6. Alright. Then we are moving on to the next question. Principal value of cos inverse of minus 1 by 2 is. You will get questions like value of cos inverse of 1 by 2 minus 1 by 2, principal value. Principal value is nothing but the value that lies in between, inside or within the principal value branches of each function. So we have to find out the principal value of cos inverse of minus 1 by 2. All right. So how will you find out the principal value? They have given you options as minus pi by 6, then minus pi by 3, then 5 pi by 6, then the last option is 2 pi by 3. Okay, so here also, in order to apply the property cos inverse of cos x is equal to x, we have to change the value inside the bracket in terms of cos x, isn't it? We have to apply cos inverse of cos x equal to x. So we have to change the value inside the bracket into the form of cos x. So that is, you have to get cos x is equal to 1 by 2. So which value of x will give you cos function as 1 by 2? Nothing but cos pi by 3. Cos 60 is 1 by 2. Cos 60 is 1 by 2. So cos pi by 3 is 1 by 2. So this can be written as, that is cos inverse of minus 1 by 2 can be written as cos inverse of minus cos pi by 3. 1 by 2 can be written as cos pi by 3. So minus is already there in the question, so it will become minus cos pi by 3. Since minus is in that question, we cannot directly apply this property. So we cannot directly apply because it is positive cos x in the bracket. So we should change this into positive. So for that, you should again apply the reduction formula. Okay. So you have to find out the equivalent angle in which the cos will become positive. So how will you find out? We can write this cos pi by 3 as pi minus pi by 3, isn't it? Pi minus pi by 3. That is cos pi by 3 can be written as cos of pi minus pi by 3. Now let's see whether this will give you this value, the left hand side value. Okay, that is pi minus pi by 3 means pi minus pi by 3 means it belongs to the second quadrant, right? Pi, here it is pi. Pi minus pi by 3, it will go to the second quadrant, isn't it? So what happens in the second quadrant? Second quadrant, you know that cos is negative, isn't it? Cos is negative. Only sine and its reciprocal cosec are positive in that quadrant. Except all other functions are negative. So cos is also negative in the second quadrant. Okay. So we have applied the reduction formula and changed this minus cos pi by 3 as cos of pi minus pi by 3. Both values are same. Cos of pi minus pi by 3 means it is negative. Okay, since cos is negative, it is negative cos pi by 3. All right. Okay. So now we can apply the property, isn't it? How will you do that? That is cos inverse of this minus cos pi by 3. I'm going to write this one as cos of pi minus pi by 3. Cos of pi minus pi by 3. Now it has become in the form of cos inverse of cos x. That is equal to x, isn't it? So here in the place of x, it is pi minus pi by 3. Alright, what is pi minus pi by 3? It is nothing but 3 pi minus pi by 3. That is equal to 2 pi by 3. It is equal to 2 pi by 3. And this 2 pi by 3, that was our last option, I think. Yes, it was our last option D. That was 2 pi by 3. So the answer is nothing but 2 pi by 3. Okay. I hope it is clear to you all. And we have to check whether this belongs to the principal value branch because they have asked the principal values in it. So 2 pi by 3 is equal to 2 into 180 by 3, isn't it? So this one gets cancelled. 60. 2 into 60 is 120 degree. 120 degree belongs to closed interval 0 pi. So closed interval 0 pi is nothing but 0 to 180. And 120 belongs to 0 to 180. So 2 pi by 3 belongs to the principal value branch. So what is the principal value? Principal value is nothing but 2 pi by 3. Okay. Now moving on to the next question. The value of tan inverse of root 3 minus sec inverse of minus 2. Okay. So we have to find out the value of tan inverse of root 3 minus sec inverse of minus 2. So how will you do this? You split this into two parts. That is, find out the value of tan inverse of root 3 and then you find out the value of sec inverse of minus 2. Then subtract each other. So we'll start from tan inverse of root 3. Okay. Tan inverse of root 3. So in order to apply the property tan inverse of tan x is equal to x, we should convert this root 3 into tan x, isn't it? So tan x is equal to root 3. Which value of x will give you tan x as root 3? It is tan pi by 3. Tan 60 is root 3, isn't it? So 60 can be written as pi by 3. Okay, tan pi by 3 is root 3. So we can write tan inverse of root 3 as tan of tan pi by 3. Tan of tan inverse of tan pi by 3. Now can you apply the property? Yes, tan inverse of tan x. Tan inverse of tan x is equal to x. And this can be written as pi by 3 if pi by 3 belongs to the principal value branch. Okay, that should also be checked. So how will you check? You should know the principal value branch pi by 3. What is the principal value branch? Open interval minus pi by 2 comma pi by 2. Isn't it? Does pi by 3 belongs to that interval? This is minus 90 comma plus 90. So pi by 3 means it is 60. 60 definitely belongs to this interval, that is the principal value branch. So we can say that tan inverse of tan pi by 3 is pi by 3. Now the second part is sec inverse of minus 2. Okay. The second part is sec inverse of minus 2. So this one was pi by 3. Okay. Now we are going to find out the value of sec inverse of minus 2. Sec inverse of minus 2. Again, if you want to apply the property sec inverse of sec x is equal to x, we have to change this 2 in the form of sec, isn't it? So, which value of sec will give you 2? That is, you think about its reciprocal, that is 1 by sec x is equal to 1 by 2. 1 by sec x is nothing but cos x. Cos x is equal to 1 by 2. Which value of x will give you the value 1 by 2? Cos x, that is cos pi by 3. Cos 60 is 1 by 2. Cos pi by 3 is 1 by 2, which means sec pi by 3 is 2. Sec pi by 3 is 2, isn't it? So sec inverse of minus 2 can be written as a sec inverse of minus sec inverse of minus sec pi by 3. Sec inverse of minus sec pi by 3. All right. Again, you could now directly apply that formula, isn't it? Sec inverse of c. If it was sec inverse of sec x, you can directly apply that property. Here it is minus, so we have to again apply the reduction formula. And we know in the second quadrant, uh, first quadrant everything is positive. In the second quadrant, you know that sec is negative, isn't it? Sec is negative. So how will you write, how will you convert this into minus sec pi by 3 should be converted into a positive quantity. So how will you do that? It is in the, we know that in the second quadrant, only sine and its reciprocal cosec is positive. So sec is obviously negative. Okay, sec is negative. So this can be written as the angles in the second quadrant can be written as pi minus something, isn't it? The general form of the angles in the second quadrant is pi minus theta. Okay, pi minus theta. So if you get if I write it as pi minus pi by 3. Okay, pi minus pi by 3 means this is pi. Okay, this one is pi, and if I subtract pi by 3 from that, you will reach in the second quadrant. In the second quadrant, sec is negative. So I'm going to write this minus sec pi by 3 as minus sec pi by 3 as minus sec pi by 3 can be written as sec of pi minus pi by 3. Sec of pi minus pi by 3. All right. Now I'm going to put it in the question. That is sec inverse of sec of pi minus pi by 3. Now I can apply the property, isn't it? Now I can apply the property sec inverse of sec x is equal to x. Okay, sec inverse of sec x is equal to x. All right. So the answer will be pi minus pi by 3. The answer will be pi minus pi by 3. All right. So what is pi minus pi by 3? It is 3 pi minus pi by 3. That is equal to 2 pi by 3. And this 2 pi by 3, we have to check this 2 pi by 3 belongs to the principal value branch. Does that belongs to the principal value branch? How will you check it? It is 2 into 180 by 3. That is equal to 120. It is 120. And what is the principal value branch of sec inverse? Sec inverse means it is a reciprocal of cos. So, closed interval 0 pi minus set pi by 2. Okay, closed interval 0 pi minus. So, closed interval 0 pi minus set pi by 2. And this is 120. Isn't it? 120 belongs to this one. So it lies between 0 and 180. So 120 it belongs to that one. That is 2 pi by 3 belongs to this interval. All right. Now we have to find out tan inverse of root 3 minus tan inverse of root 3. Tan inverse of root 3 minus sec inverse of minus 2. That is equal to pi by 3 minus 2 pi by 3. That is equal to minus pi by 3. Isn't it? Pi by 3 minus 2 pi by 3, that is equal to minus pi by 3. So this is the answer. Now moving on to the next question. Sine of pi by 3 minus sine of minus 1 by 2. The value of sine of pi by 3 minus sine of minus 1 by 2. So we should start from here, right? We should start from here. So that is sine of minus 1 by 2, which means 1 by 2 should be written in the form of sine. So sine of which value sine x is equal to 1 by 2. Which value give you 1 by 2? This sine 30. Sine 30 can be written as pi by 6. Sine pi by 6 is 1 by 2. So I'm going to write this one as sine of uh, pi by 6. Sorry. Minus pi by 6. And 1 by 2 minus is already in the question, and this 1 by 2 can be written as sine pi by 6. Okay, so I'm replacing sine of this 1 by 2 as sine pi by 6, and except all the other same in the question. Okay, sine minus 1 by 2 can be written as sine of minus sine pi by 6. Okay, so it is sine inverse actually. This one is sine inverse. Okay, sine inverse. I'm sorry, the sine inverse. Okay, so and we know the property of sine, that is sine of minus x can be written as minus sine x. That is the minus inside the bracket can be taken outside in the case of sine function, and as well as tan function also. But cos function we cannot do in that way. So that's why we use the reduction formula and all in order to solve such type of questions. That is, when negative came in the cos function and sec function and all, we applied the reduction formula in order to convert. But in the case of sine, it's reciprocal cosec, then tan, as well as its reciprocal cot, we can directly use this property. That is, if a if a minus comes inside the bracket, we can take it outside. So if a minus is outside the function sign, we can take it into the angle. Okay, so this can be written as sine inverse of this minus. I am taking it inside to the angle. Okay, that is pi by 6 became minus pi by 6. Now we can directly apply the property sine inverse of sine x is equal to x. Here x is minus pi by 6. So the value will be minus pi by 6. Minus pi by 6 means uh, it is minus 30. Isn't it? Minus pi by 6 means minus 30. So this belongs to the principal value branch. What is the principal value branch of sine inverse? Closed interval minus pi by 2 comma pi by 2. This is minus 90 to plus 90. And minus 30 means it lies in between this. Isn't it? Minus 30 comes after minus 90. So minus 30 belongs to this one. So we can say that the value of sine inverse of minus 1 by 2 is nothing but minus pi by 6. Okay, now I'm going to erase this. Okay, so we have found out a part of this question. Now we are going to apply that one. Okay, that is sine of pi by 3. There is already a minus. Now we got the value of sine inverse of minus 1 by 2 as minus pi by 6. As minus pi by 6. So this is equal to sine of pi by 3 plus pi by 6. Pi by 3 plus pi by 6. So what is the value? If you cross multiply this, this will become 2 pi plus 2 pi plus pi by 6, isn't it? So that is equal to sine of 3 pi by 6. Sine of 3 pi by 6, if I cut short like this, it will become sine pi by 2. What is the value of sine pi by 2? It is nothing but uh, sine pi by 2. It is sine pi by 2, okay? Sine pi by 2 is not 1 by 2. Sine pi by 2 means sine 90, isn't it? Sine 90 is 1. Okay, so 3 pi by 6, the value is 3 pi by 6. Isn't it? 2 pi plus pi, that is 3 pi. 3 pi by 6, if I cut short, it will become pi by 2. Sine pi by 2 means sine 90. Sine 90 is 1. The value is 1. Alright, now we are moving on to the next question. Domain of the function, domain of the function, sine inverse of x plus 1. Okay, domain of the function sine inverse of x plus 1. So what is the domain of this function? How will you find out? We know that sine inverse x, the domain of sine inverse x is nothing but closed interval minus 1 comma 1. That is, the x value lies in between minus 1 and 1. Here, instead of x, they are given as x plus 1. Okay, you have given it is as x plus 1. So we have to find out the range of this x plus 1. We know the range of x. So how will you find the range of x plus 1? Since you know the range of x is minus 1 less than or equal to x less than or equal to 1. Since the function is sine inverse, we know the x value or the domain of the functions varies in between minus 1 and 1. So how will you rewrite this? We have to find out the range of x plus 1, right? So you have to write that is x plus 1 should also vary in between minus 1 and 1 because it is the value of the inverse function sine. So it should definitely varies in between minus 1 and 1. So x plus 1 should also varies in between minus 1 and 1, which means here 1 is extra. So how will you remove 1 from this x plus 1? You should subtract minus 1, right? So if you subtract minus 1 from this middle portion, you should subtract it from minus 1 as well as 1 also. Okay, so minus 1 less than or equal to x plus 1 minus 1 less than or equal to 1 minus 1. Okay, so minus 1 will become minus 2 less than or equal to x plus 1 minus 1 will become 0. That is, it is x itself less than or equal to 1 minus 1 is 0. So the x varies in between minus 2 and 0. All right. So which means x belongs to minus 2 comma 0 or the domain is closed interval minus 2 comma 0. All right. Now next one. Similarly, they are asking about the domain. Okay. Domain of the function sec inverse of 3x minus 2. Okay. Sec inverse of 3x minus 2. So what is the domain of sec inverse x? What is the domain of sec inverse x? The domain is r minus 1 1. Isn't it? R minus 1 1. Sec means cos reciprocal of cos. So r minus 1 is the domain of sec. which means this can also be written as, that is, we are removing all the numbers in between minus 1 and 1 from the set of real numbers. That is, minus 1 and 1 are included because it is open bracket, right? So in between, all the numbers are removed from the domain. In between minus and 1, the numbers in between minus and 1, minus 1 and 1 are removed. Okay, so how can you rewrite this? You can write this one as minus infinity comma minus 1 union, isn't it? Minus infinity up to minus 1 is included. But minus 1 and 1 are not included. Numbers in between minus 1 and 1 are not included. So we have to remove that. I have removed it. Now it starts from 1 to infinity. You can write this one like this, isn't it? That means the domain of the function sec inverse will be, that is, the x values will be less than minus 1 and it will be greater than 1. Okay, less than minus 1 and it will be greater than 1. Which means this value can only take less than minus 1. Similarly, it can only take values greater than 1. Okay, so we'll get two parts on solving this. That is, 3x is less than minus 1. This one, 2 goes that side, it will become plus 2. So 3x is less than 1, x less than 1 by 3. And similarly, if you solve this one, you'll get 3x greater than 1 plus 2. 3x is greater than 3. X is greater than 3 by 3. That is x greater than 1. Which means x can take values greater than 1 and values less than 1 by 3. Okay, this particular x can only take values less than 1 by 3 and greater than 1. So how can you write this in the form of like this? That is, you take only values from less than 1 by 3, means it can extend up to minus infinity. Minus infinity comma 1 by 3 union 1 comma infinity. Okay, it can take values also which is greater than 1. So 1 to infinity is also included. Okay, so this is the domain of that particular function. Now, we are moving on to the next question. Okay. So the domain of the function sine inverse of x square minus 4. Sine inverse of x square minus 4. Again, we know sine inverse, the domain varies in between minus 1 and 1. So x square minus 4 can only take values in between minus 1 and 1. So minus 1 less than or equal to x square minus 4 less than or equal to 1. So minus 1, this if you want to remove this minus 4, you should add 4 with that, isn't it? So this can be written as minus 1 plus 4 less than or equal to x square less than or equal to 1 plus 4. Minus 1 plus 4 means it is 3. 3 less than or equal to x square less than or equal to 5. Now we need the value of x only. So you should take the root, isn't it? So plus or minus root 3 less than or equal to x less than or equal to plus or minus root 5. So how can you write this one? This can either be minus root 5 less than or equal to, because minus root 5 is less than minus root 3. So you should write like this, isn't it? Minus root 5 less than or equal to x less than or equal to minus root 3 and root 3 less than or equal to x less than or equal to root 5. So this I have converted it into 2. Minus value I grouped together and plus value I grouped together. All right. So this can be written as closed interval minus root 5 comma minus root 3 union closed interval root 3 comma root 5. Okay. So this is the domain of that particular function. Now moving on to the next question. If x is equal to sine inverse of 3 by 5, if x is equal to sine inverse of 3 by 5, then which of the following is true? Which of the following is true? First one is x equal to cos inverse of 5 by 3. Second option is x equal to tan inverse of 3 by 4. Then x equal to cosec inverse of 5 by 4. And D is x equal to cot inverse of 3 by 4. Alright. So x is given as sine inverse of 3 by 5. and they are asking which of the following is true. Okay, here since x is equal to sine inverse of 3 by 5, that is sine inverse of 3 by 5. I'm just writing in the reverse order. 3 by 5 can be written as sine x, right? By using the definition of inverse, if x is equal to sine inverse of 3 by 5, we can write 3 by 5 as sine x. So if you construct a triangle, right triangle like this, let this be 90 degree and let this be x. So here sine x is 3 by 5, which means sine means opposite by hypotenuse. So opposite side is 3 and hypotenuse is 5. Okay, sine x is equal to 3 by 5. So what is the value here? This will be 4, right? That is root of 5 square minus 3 square, that is equal to root of 25 minus 9, that is equal to root 16 is equal to 4. So the value here will be 4 by using the Pythagoras theorem. Okay, so we have got the value of the adjacent side of that angle, which means what is the value of cos x then? Cos x means nothing but adjacent side by hypotenuse. Adjacent side by hypotenuse. Adjacent side is 4 and hypotenuse is 5. So it is 4 by 5. Cos x is equal to 4 by 5. So x is equal to cos inverse of 4 by 5. X is equal to cos inverse of 4 by 5. So here they have given us cos inverse of 5 by 3. So it is wrong. It is wrong. Now what about tan x? Tan x is opposite by adjacent. Opposite is 3. Opposite of angle x is 3. 3 by and adjacent is 4. So it is 3 by 4. Tan x is 3 by 4. So what is the value of x from here? X is equal to tan inverse of 3 by 4. X equal to tan inverse of 3 by 4. So option B is correct. Alright, option B is correct. Now we are moving on to the next question. So this will be the last question of the session. That is cos of sine inverse of 5 by 30. Cos of sine inverse of 5 by 30. Okay. So what will be the value cos of sine inverse of 5 by 13? Again, we can write the sine inverse of 5 by 13. If sine inverse of 5 by 13 is x, 5 by 13 can be written as sine x, isn't it? So if you construct a triangle like this is 90 degree and let this be x. So the opposite side here, opposite is 5 and hypotenuse is 13. So opposite is 5, hypotenuse is 13. So what will be the value here? How will you find out root of 13 square minus 5 square? That is equal to root of 169 minus 25. Root 144, that is equal to 12. So this side we have got the value as 12. Adjacent side is 12. So what can you say about cos x from this? Cos x is equal to adjacent by hypotenuse. So adjacent is 12, hypotenuse is 30. So it is 12 by 30, isn't it? So here we have put sine inverse of 5 by 13 as x, isn't it? So this will become cos x. This will become cos x. And what is the value of cos x? We have got it as 12 by 13. So the answer of this question is cos x is equal to 12 by 13. 12 by 13 is the answer. All right. So we have discussed almost all the important questions that may be asked for the 1 mark question. Okay. So the most important among this is the first type of question that we have discussed, that is the domain as well as the ranges of inverse trigonometric functions. It can be directly asked, and then finding out the principal values of those functions. Okay, principal value, and if two functions may be together given, and we have already solved such type of questions. So these are the very important questions among the 1 mark question. I hope this session was very useful to you all, and thank you.